So if you don't already know what L'Hopital's rule is, then I would suggest watching our video on it, and I'll link it in the description. But after watching that video, or if you already know what L'Hopital's rule is, then let's say you have this limit as x approaches 0 from the positive side, or the right side, of x to the power of x. And here direct substitution won't work, so we'll have to use a trick involving natural logarithms. So let's set x to the power of x equal to y, and then take the natural log of both sides. So ln y is equal to ln of x to the power of x, but using the properties of logarithms, we can just move the exponent x onto the left to make a multiplication. And then since ln is just log based e to the power of this equals this, we can rewrite this as e to the power of x ln x equals y. And now, since y is equal to x to the power of x, and that's what we're taking the limit of because we set it equal in here, then we can say we're also taking the limit of this. So let's rewrite our limit as x approaches 0 from the right side of e to the power of x ln x. But we can probably notice that since everything is on the exponent, like all the x's are on the exponent, what we're really trying to find is the limit of x ln x, and then raise e to whatever that is to find our answer. So first, let's find the limit as x approaches 0 from the right of x ln x. And we can rewrite this in a way that will allow us to use L'Hopital's rule. So let's rewrite it as ln x over something, which will be 1 over x in this case, because we're multiplying by x, which is the same thing as dividing by 1 over x. And then if we just plug in 0 into this, we get an indeterminate, negative infinity over infinity. So let's use L'Hopital's rule. Take the derivative of ln of x, and we get 1 over x, and the derivative of 1 over x is negative 1 over x squared. And if we multiply both the numerator and denominator by x squared, then we just get negative x. And the limit as x approaches 0 from the right side of negative x is just 0. But again, this is not our final answer. We have to plug it back into here. So in reality, our final answer is e to the power of 0, which is 1. And that's our answer. So I know that was pretty hard to follow, so I'll just give a recap of what we just did. So first of all, we looked at this limit and noticed that direct substitution would not really work. So we set x to the power of x equal to y. And then we manipulated it using natural logs to set e to the power of x ln x equal to y. And since this is now equal to y, this is also equal to x to the power of x, meaning that we can rewrite our limit as this. And now that we've rewritten our limit as this, it's much easier to do. We simply focus taking the limit of the exponent first because there's no manipulations being done to anything else in the equation. And then we rewrote this as a fraction so that we could prove it's indeterminate and use L'Hopital's rule. Just looking at x ln x, we can't use L'Hopital's rule here, but rewriting it as a fraction, we could, and we got 0 as our limit. But 0 wasn't our final answer because we had to plug it back into this. So since we already have x ln x, we just plugged in 0 for that, and we got 1. Now, let's get into some practice problems. If you think you know how to do this one, then pause the video and do it. This one says, evaluate the limit as x approaches 0 from the positive side or the right side of 1 plus x all to the power of 1 over x. And to do this, you just use the same steps that we did in the example. So you set this, the expression, equal to y or another variable, and then you take ln of both sides to rewrite this in order to rewrite our limit as something easier. So ln y is equal to ln of 1 plus x to the power of 1 over x. But using the properties of logs, we can move this 1 over x to the front it just becomes over x. And we can rewrite this as e to the power of ln of 1 plus x all over x is equal to y. And since this is equal to y, this means that this is equal to our original expression that we're evaluating the limit of, which also means that we can rewrite our limit as the limit of x approaches 0 from the right side of this. And now you can probably notice that same thing as the last problem. We move the limit to the exponent and solve for that, and then raise e to whatever that is. So we find in the limit as x approaches 0 from the right side of ln of 1 plus x over x. So let's rewrite it here. And now we have to prove that it's indeterminate in order to use L'Hopital's rule, because direct substitution here will not really work. Of ln 1 plus x over x. If we substitute 0 into ln of 1 plus x, we get 0. And substitute 0 into the denominator, we get 0, which is indeterminate. And now we can use L'Hopital's rule to take the derivative of ln of 1 plus x, which is 1 over 1 plus x. And the derivative of x is just 1. And this is equal to 1 over 1 plus x. And now this is easier to evaluate the limit of. If we do direct substitution, we get 1 over 1 plus 0, which is 1. And now we just substitute 1 into e to the power of that, and we get e to the power of 1 is equal to e. And that's our final answer. And now let's do one last practice problem. If you think you know how to do this one, then pause the video and do it. This question asks to evaluate the limit as x approaches infinity of x to the power of 1 over x. And again, it's the same steps as the two problems we've already done. So what we need to do is set x to the 1 over x equal to y or another variable and take ln of both sides. So ln of y is equal to ln of x to the power of 1 over x. And if we move the 1 over x to the front, then we get ln x over x. And we can simply rewrite this as e to the power of ln x over x is equal to y. And then since this is equal to y and y is equal to our original expression, then we can rewrite it as, we can rewrite our original limit function or expression as this, the limit as x approaches infinity of this. And then again, we evaluate the limit of the top and then raise e to whatever that is. So the limit as x approaches infinity of ln x over x. We have to prove this is indeterminate. So if we plug in infinity to ln x, we get infinity, and x, we get infinity as well. So it's indeterminate. And then using L'Hopital's rule, we can rewrite it as the limit as x approaches infinity of 1 over x over 1, which is just simply 1 over x. And now this is much easier to evaluate. As x approaches infinity of 1 over x, it's simply just 0. And now we plug it back into e, so e to the power of 0 is equal to 1. And that's our final answer. So everything that I just explained and all the problems that I went through should teach you everything that you need to know about using natural logarithms along with L'Hopital's rule to evaluate limits. If you learned something from this video or if you enjoyed it, then please consider liking and subscribing.